Well, thanks for attending an afternoon session, especially after the horse race, right? I mean, we've seen all that. So we're going to talk a little bit about operating OpenStack using a container-based service. I did a previous talk where I talked a little bit about Kubernetes as a management layer for a container-based environment. In this case, I want to talk a little bit more about the actual operations of containers, sort of things that you might want to be aware of. We'll talk about a bunch of these things. So first off, who am I? I founded a little technology company, a little boutique capability. We help people transition into cloud. And the customers that we've worked with, we've helped them understand sort of the types of cloud services they need, the kinds of infrastructure they want. And when they were looking for private cloud services, we've helped them actually build and install those, whether they be pure OpenStack or a Kubernetes-based system or just even based Docker types of resources. That's kind of where I'm coming from when I talk about these sorts of things. So I want to start by first looking at why we even are interested in containers. What is it that's driving this concept of containers as a part of our middleware? And I start by thinking about, in my abstract, I said, I'm talking about democratization of operations through containers. Now, I said that because I was thinking about the fact that many operators, if you have a very complex system that you're operating, have to effectively know as much as the application developers about the application in order to actually operate that environment. I think containers really change the worldview a little bit. It's easier to be almost a generic operator because you have to think a little bit less about what the application is trying to do and can focus more on what the infrastructure is trying to support. So it really sort of changes the game. We simplify the process of upgrading. We simplify the process of just managing the resources because of what containers do. At the same time, making things easier isn't always perfect because by adding this layer of containerization, what that means for an operator is that I have to start thinking about what those containers require. So I have new services that I have to manage, where in the past maybe I just managed Linux operating systems. Now I have to manage the operating system plus the container management services. So there is a little additional work that has to go into doing this. So I like to start by thinking about what a container is, right? Because I think some people have these really interesting thoughts about what containers are and what they can or can't do for you. But to me, containers are really technology components that simplify the packaging of our applications. Right, so it makes it easier to actually manipulate the actual application because I've bundled everything together. And this dependency hell that we've seen when trying to upgrade some OpenStack environments, for example, goes away when I package things in containers. Because I've defined the dependency for a particular running process by bundling all those resources together in that image. And that's what creates then my container image. Whether it be something like the Docker format of image or even LXC, I've kept all of my resources together. So when I launch that particular container resource, I don't really have to worry about what anything else on that underlying machine is using. Right? So that's what, to me, a container is really all about. It's a packaging mechanism. Application developers love it because of that. I think operators are going to start loving it if they haven't already for exactly the same reasons because of that simplification. Right, and this little diagram here tries to, let's see, do I have a laser? Yeah, this little diagram sort of tries to highlight that, right? I have my hardware, the classic things that I operate, my x86 system, on top of that, a host operating system, and then I do have this one piece, this new piece of technology, my container management resource that I do have to deal with. But my application is bundled together with its specific libraries, all the resources it needs to run, but I don't have another operating system embedded in there as well. Right? So again, that's the benefit of the containerization environment. Yeah. So the reason that we're talking about containers, though, is not because operators saw them and said, hey, this is a great thing. It's because application users suddenly saw the value of containerization. What is it now, 3.5 years ago, when Docker said, hey, we've got a simpler way of building and using containers, the community shifted almost overnight. I mean, I don't know if you saw the same experience that I did, but people were not talking about containers, except occasionally they were saying, yeah, we could use this LXC thing. It kind of simplifies some stuff. It makes things look a little bit nicer, but it didn't really take off. Docker came on the scene, and suddenly nobody in the application community wanted to talk about anything other than containers. Why was that? Well, it really was this dependency containment process. The ability for an application developer to say, here's my application, I've bundled together with all the things that I know it needs, the exact versions it needs, the exact code that it needs to run properly. I can hand that off if I need to a QA organization. They can now test exactly the same code that I was working with. That's incredibly compelling. I can take that exact same code now and put it into production if it passes all the additional tests that I might have in a staging environment. From an application developer's perspective, this is brilliant because they don't get operators coming back and saying, well, you may have said it worked, but I can't get it to run. Why? Well, I have a slightly different dependency. When I install Red Hat Linux, I get slightly different versions of things than when you install it. Nightmare sorts of code issues that people run into because of micro version discrepancies, right? So application developers love it because of that, and that helps simplify ops. We'll talk more about the upgrade-downgrade process a little bit later, but that's another key thing. Again, operators now are starting, I think, to love this because operators are running more and more middleware. I think in the past, operators looked at just the operating system. That was the closest that we had to middleware. Maybe we were dealing with tools that managed our operating systems, managed the upgrades and the processes behind them. That's now starting to shift. Now we have to run OpenStack. Now we have to run Kubernetes. Now we have to run all these other tools in addition to the infrastructure, in addition to the base operating system that we're working with. Right? So when we take those same benefits, this simplification of what our resources look like, it starts to really help us when we're running middleware. The other part of this puzzle, though, is that we don't have to know quite as much, like I said earlier, about our applications, what's running on top of us. In a sense, this was one of the reasons that I think OpenStack and the whole virtualization space took off when it did 15 years ago. Right? Because the operators could say, well, I've given you a platform, you're running your own operating system and everything above it on top of that, I don't care anymore. I can just make sure that your virtual machine environment runs well. Right? There are problems with that. There are security issues for those virtual operating systems that maybe the operators sort of took a back seat on. But I don't have to deal with that anymore. Right? And containerization gives me a second version of that. I don't have to deal with that infrastructure. Right? So another part of this is potentially part of the upgrade cycle. How many people here have actually tried to upgrade an OpenStack system? How many people have done it successfully? Okay, so there are a couple, always a couple, right? How many did it without containers? Right. So we see that these are problems that people have had, right? Upgrading is not an easy process. It can be done. Downgrading is a nightmare. I don't know if anybody's even tried to downgrade an OpenStack system. Usually you just reinstall and hope you can get the thing back up and running to a consistent state. But that upgrade-downgrade process is something that's often a problem, not because of the code base itself, but because of the dependencies that get created, when you install all the ancillary services needed to run a particular application. All right? If I can bundle all those together, now my upgrade-downgrade process looks like, well, run container A or container B, and if container B doesn't work, as long as it didn't change state too dramatically, I can go back and run container A again. That change of state is still one of the biggest problems that we have to deal with, but potentially I can upgrade and downgrade a service, especially a stateful service, just by restarting a container, restarting all the processes that go with it. That is huge. That is a really compelling benefit from an operator's perspective. I don't have to know what the code does. I don't have to know what the dependencies are. I can forget all of that. So is everything perfect because of this? No, of course not. Right? There are new skills that we have to come up with. There's new infrastructure that we have to operate. There are changes in how we start thinking about how these services interact. Right? There's even differences in service visibility. Do you know how to find the logs in a Docker environment? Not the logs that Docker spits out, because those probably aren't really that useful to you, but the actual log files that get written? No? Right. Yeah, right. There are ways to find it. So that's one thing, right? So that's one part of the story. Containers are good. We like containers. Let's do more containers. But let's talk about containers and OpenStack. So to me, where this story always starts is, what does OpenStack as an application really need? And is a container environment going to be able to address that? All right, so I always break it down into a couple of key things. OpenStack is an application. It's a dramatically distributed application. It has both stateful and stateless components. And there are lots of components that get involved. Right? Some are custom built. all of the services. Some are third-party application components, things like Rabbit and the databases that support all the state. So those things all have to be dealt with. So can I look at resiliency and service availability and potentially failure recovery? All I kind of consider that part of the availability and monitoring pieces. And then upgrades and updates. How do I deal with these pieces? So if I start with the resiliency, I mean, I know when I'm looking at deploying a system that isn't just for one user or one small development team, I'm always going to start thinking about resiliency. How do I make sure that if a physical machine dies, or if I'm running this as virtual machines, if a virtual machine dies, that my operations middleware continues to run? Well, I'm going to have multiple versions of something. If I have multiple versions of something, I have to have load balancing as a capability. If I have load balancing as a capability, maybe I need to have service anti-affinity because it doesn't help me to load balance 3 things on one machine if that machine dies, right? So that's kind of, to me, the core of what I think of in terms of resiliency. So do containers help? Well, running multiple versions. I mean, if I can run one version, I can hopefully run multiple. Containers containerize my application resources, so maybe there's some benefit here, right? Container services in and of themselves do not provide load balancing service, so that's a wash, right? Service anti-affinity, maybe it's easier to run multiple containers on multiple different machines, so maybe I can actually even get the anti-affinity component out of containers, although, again, maybe that's really a wash, because I can do anti-affinity by running processes on different machines. All right, so there's nothing within the core container resources that helps here. Right? When I start thinking about container operating environments, get another layer of operations on top of all of this, I get even more of these capabilities handed to me. But the core containerization really provides mostly multiple service versions and potentially even multiple disparate service versions running on the same machine as a capability, something that maybe I really didn't have before. Right? So that's thinking about resiliency. Availability of monitoring and alerting. Right? What am I getting out of my monitoring and alerting to begin with? Is a service available? Right? Well, containers don't help me with is a service available, although it's a lot easier to know if my service is running, because if my container is running, then that service, the application within that container has to be running. Right? Otherwise, the container is in some failed state of itself because there's only a single process active in a single container. So I do get some interesting ability to understand service availability from container availability. Is this really different than process availability? I'm not so certain, but at least we know it's all bundled together, right? So we know that that container process, if it says it's running, we know that our system should be available. Do I get automatic recovery or alerting from my container environment? Most systems these days, so LXC leveraging systemd or Docker using its Docker daemon, will actually try to restart a service if it fails. So by default, I actually get some automatic recovery attempts, at least. Now, if I've corrupted the state of a database, that's not going to help me. But at least I have the ability to see that something's happening, and I can start logging that information and use that logging information to tell me how my system is behaving. Did I really lose one of my multiple services because something got corrupted or not? Right? Interestingly enough, I think we can also use some of the container knowledge to improve our performance. Because one of the things that we often do is if we need multiple API services running, we'll kick off multiple threads on a single machine. That might be one approach to doing this. With containers, since I've containerized the individual process, I potentially can launch multiple container processes because I'm consuming the same effective resources. In addition to this, I can start really fine-tuning my resources because I can monitor the resources that an individual container uses a little bit more effectively, I think, than an individual process. Right, so now I can start dealing with scale in a slightly different way because of the monitoring that I can accomplish from the container space. Right? Now, there are other failures as well. When I'm thinking about monitoring, often in the container world, I think about stateless service. In a sense, this is kind of the space that the container world really took off with. You guys have probably heard of functional or serverless computing as well, right? The extreme version of stateless applications. Basically a containerized application that just runs as if it were a function to some other application, right? That's really nice because there I have auto recovery. If a function fails, it just starts another one, right? Something else has to do that start. And that's a stateless environment. What happens if a stateful application component fails? How do I deal with that recovery? Turns out containers don't really help except for the fact that at least my process code is bundled together cleanly. Right? So I could, if my system can handle it, I could start yet another entity with an empty data set and potentially recover from one failed node. Maybe a little bit more simply than a statically defined virtual machine with virtual storage, because there is some better automation for how the storage gets mapped in the container environment. So dealing with failures, containers, I think, have some value for us, right? But the big one I still think is in the update or upgrade space. I mean, I've worked with enough OpenStack systems where I'm trying to upgrade one component in the environment, and that upgrade breaks everything else, just because that component has a newer requirement for one Python library, right? I'm sure most of you, if you've tried, realize that that's something that you have to be aware of. You have to deal with that by potentially upgrading everything at the same time. A little bit more complicated upgrade process to do it that way. Clearly feasible. I think many of you said that you've actually accomplished successful upgrades of the entire OpenStack system, right? Containers simplify that process because now I can truly upgrade one process, or depending on how I built my containers, one service at a time. And if it doesn't work, so long as I have a snapshot of my previous stateful set, my previous database, I potentially can recover very quickly, because I can just recover that one database component and rerun the old image. My old container can be restarted. Now I'm back into a running state, right? That part, I think, is probably the #1 most powerful component of why containers are so compelling from an infrastructure management perspective. Downgrades would be nice too, but again, we have the same problem of how do I downgrade updated data? You know, dealing with schema mismatches, I don't know that we really want to deal with this. So when we think about what we need to be able to do this, right, I think I'm starting to hopefully paint for you a compelling reason why containers are a good use case or a good tool for our middleware management. I think there are a couple of key skills. For me, today, it's all about Docker. Right? Docker is really the service answer here. LXC is another solution, and the folks that do the OpenStack Ansible project are LXC focused. So there is certainly a model for that. But the interest I'm seeing and the ability to learn these skills and make them useful for future work, I think really points us towards the Docker direction. So we need to understand the life cycle of a Docker environment. How do you deal with Docker as a service rather than just containers? Well, what does that mean? That means I need to understand Docker in infrastructure. I need to understand the networking in the Docker space. Luckily for OpenStack, at least, this can be very easy, because the way that most OpenStack services talk to or to leverage the container environment is in host mode, which means that they're basically saying that the port that we know is exclusive to a particular service. Probably get it wrong, 9773 for Nova API, I think. Something like that, right? That port is unique on a host. So it's okay for me to take the container and just say, hey, I'm going to expose this container on a specific port on this host. Now that does mean that I can't have two versions of the Nova API on the same port on the same physical host. But often that's not what I'm trying to do, right? Like I said, with resiliency, I really do want to have anti-affinity for host services. And if I want one version of the Nova API running, I only want one container running that on a host. So the networking is actually fairly simple, but it is something to be aware of. And Docker networking can be complicated in and of its own right? So something to look at. Management commands for the Docker environment, both managing Docker as a service, making sure that all your Docker services are running, which is really only one, but then also managing Docker-based processes. Even if you have another tool like the Kolla Ansible tools for actually managing the deployment and launch of Docker services, you still are going to eventually have to understand what your Docker instances themselves are doing. And lastly, use of exec, which is a very powerful tool, but also one that I think currently is being used to allow operators to act like we did in the past. Well, let me go log into that thing and fix that thing, instead of let me figure out what's broken with it, get the code to be fixed, and then restart that thing with a new image, which is a different way of looking at service. The other tool that I think we really need that I don't know how many people have at this point, I still do a lot of classes on Ansible, so I'm assuming not everybody has Ansible skills, but Ansible has really become the tool of use against Docker-based environments. And in the OpenStack community, there are two separate projects that all focus on containers, and they use Ansible as their deployment automation tools. All right, so you're going to run into and need to have some experience and skill with Ansible. Luckily for most of us, it's a very easy language to learn, but it is another tool that you have to add into the environment. And it gets used for a couple things. One, for configuration management, much like Puppet or Chef or any of the other sort of CAPS-based tools. And the other is for image creation, because I still want to be able to create an image of the current version of the OpenStack code, as an example. All right, so how do I do that? That's where our image build templates come from. And currently, most of the work has been done in the Ansible space for that. I actually haven't, I know that the Salt folks, Salt Stack, actually had some work in a similar vein, but I haven't actually run into it very much. So, yes?
I'm familiar with Kolla and how it uses Ansible.
Yeah.
This OpenStack Ansible images, that's a separate thing? Or is that?
No, that's OpenStack Ansible deployment, OSAD. I think I missed a term there. So Kolla images or OpenStack Ansible images, there are two sets of image creation tools, right? OpenStack Ansible is OpenStack Ansible deployment, I guess. OSAD is another project. It also creates container images, but its focus is LXC-based images, right? Yeah, so the only tools that I've seen that are in the open source that I'm aware of, and there may be others, but the ones that I've seen are the Kolla tools. But aren't they also using Kolla tools to build their containers? I don't know either. So I don't know what the current state of OO's containerization process is, if they've built their own tools. I know OO is heavily Puppet-based, right? So maybe they've written some Puppet tools to build the images that they need. Last I heard, I thought they were going to leverage the Kolla work.
I think Kolla for building the containers and then using Puppet orchestration.
Yeah, this is what I'd heard as well. Right. So to sort of complete that thought, there are two current projects that are part of the OpenStack community that are focused on containerization. They have two slightly different focuses, or foci. One is the OpenStack Ansible deployment project, and that focuses on using LXC as the container format, right? So they build their own containers. They have a process for doing that as a part of a deployment process. And they also then use Ansible to configure. Because of the way that LXC works, the way they're currently using it, the configuration looks much like configuring a virtual machine running an individual service. Right, so the LXC containerization really lives at the service level. So Nova, deploy all of Nova Control, for example, in an LXC container. And then to configure it, you log into that container as if you were just SSHing into a virtual machine. Right, now Ansible does that for you. That's exactly how Ansible works to go create those configurations. So they're system level containers. Now there is some work going on to make them process level containers. So the same build process, but instead of running what looks like a mini VM, you're really running just the processes that are needed within that containerized environment. All right, so there's some work going on there. The other is the project that I've done the most work with, or I've used for the customers that I've worked with most, and that's the Kolla project. And in that, there really are two sub-projects that are interesting, at least for this particular talk, and that's the Kolla project itself, which focuses on building containerized images. One of the things I like about it is that it's actually very flexible, so you can add additional plugins, you can write your own plugins and add them into any of the services that get built in those images. So you have quite a bit of flexibility in using that engine to build images specific to your environment. And then the other one is the Kolla Ansible project, and that's a project that focuses on two things. One is configuration. How do I make sure that Nova has the right configuration components, but also effectively deploying and enabling those containers to actually be launched, right? The OpenStack Ansible deployment project does all that in one project. Kolla has broken it out into two. The Kolla project also has a third extension, which is the Kolla Kubernetes project, which really just uses the Kolla build components and a different set of automation using the Kubernetes, well, the Helm project, which is a part of the Kubernetes community, to sort of manage its launch and automation. All right, so like I said, slight side note, but I think that's important to understand those two projects. So as this was intended to be a slightly more intermediate conversation, I wanted to get through all that preamble and yet still hopefully have enough time to talk a little bit more about some of the internals, some of the things that I've run into that if you haven't run into this sort of environment, this might be useful information to gather. So for one, in the LXC case, like I said, SSH is effectively still your friend. You still log into an LXC container, at least in the OSAD current model, and can manipulate those resources just like anything else. All right, so if you're an operator and you're comfortable working with virtualized systems, virtualized machines, then this is a very simple thing to fall into and use. And I think that's one of the reasons that some of the folks that are using OSAD really like it. It's just like anything else that they've worked with. I don't think we get all of the benefits of the environment, of the containerization environment by doing that, but again, it's not a bad model. And for configuration, things look very similar. We can go and log into the machine and see what configs were written and what they're actually using. The Kolla-based model uses a volume mount model. So basically the configurations are written external to the containers and are mounted into the containers as a volume. So they become available in that fashion. That's interesting because now I can look from one place to see all the configurations for the resources that might be running on that. So if I have 3 controllers, for example, each of the controllers will have an etc Kolla directory with all the configuration for all the different services. 2 different ways of approaching the problem. I'm not sure that one is any better than the other, but the Kolla model certainly works. The other thing that happens with configuration management, though, is that we'll find the need to change configuration from time to time. Right? In either case, Ansible is really our key benefactor here, more so than the containerization specifically. But by using the Ansible resources, we can reconfigure our particular services. And because Ansible is smart enough, we can actually then use Ansible to determine which services need to be restarted. And that's where we get another container-based benefit, restarting a service versus restarting a VM. And this is true for the LXC model as well as for the Docker container model, is very fast. Right? Restarting an LXC container or a Docker container is often on the order of milliseconds rather than seconds or tens of seconds or even minutes in some cases for a VM-based environment. Right? And I think that's one of those real power components that isn't directly obvious from the fact that you can say, well, I can reconfigure my system because I have a configuration management tool. Well, that configuration management tool also happens to tie into, and in these 2 models specifically, provides a way for running the system. Right? And that operations component is really powerful. Now, there is no current SLB integration, and actually Ansible ties to parallelize things. So if you reconfigure Nova, you're going to take your Nova API offline for at least a couple seconds. Right? Why? Because you're going to restart all 3 Nova API services at basically the same time because you've told them they've been reconfigured. Right? So it's just something to be aware of, that that's not something that's currently in there. At least I haven't seen it. This is the experience that I have. So something that I think could actually be implemented, there is absolutely the ability to order things within Ansible, and that's really, again, where this would come from, to actually manage those services being manipulated like that. The other thing is that for debug, we know that we don't want to run a production system with debug on, but if you really do need debugging capabilities, if you need to turn debug on for a configuration, you have that ability. Again, the performance is there so that especially for an API-driven interface, as long as you're not servicing a public cloud with thousands of interactions a second, it's quite possible that you could turn debugging on before anybody actually even tried to implement another API request into your system. All right? And you can then turn it off after you found the bug that you're looking for or the data that you're looking for. All right? So you're not going to fill up your logs with debug data that you really don't want to see. All right? So that's something else to think about from the configuration management perspective. And I think containers help make that happen. Now, there's another piece of the puzzle that I think is interesting to look at, and that's volumes in containers. And in this case, we're not talking about virtual machine volumes. Right? We're talking about volumes that are being used at the container level. So in the Kolla space, volumes, like I said, for even our config files are mapped into our container. And that's using the Docker volume mechanism for basically statically naming a volume being mapped into a container environment. There are also dynamic volumes. So you can create a container whose job is exclusively to basically have a pointer to a volume. And those, while they're named, are still not in a default file system place. Well, they're the default, but the default is varlib docker. This is not usual, so it's sort of a gotcha, something to be aware of. If you start looking for your log files, especially in a Kolla deployed environment, they're going to be under varlib docker, not in varlog. Which I still find odd, but that's the way the system has been set up. All right. Now, the other thing that ends up in that same environment, at least with the way that Kolla sets up its containers, are things like databases. So if you're looking for the database to back up for your Galera or MariaDB database for your OpenStack system, you're going to find it as a file in varlib docker. This also means that if you need to think about disk space for things, varlib docker is where you want your disk space to exist, right? Do glance file-based images, they're going to end up in varlib docker, right? So don't have a single root file system that is supposed to cover everything and is only 50 gig because that's what Canonical decided should be the default. It's not going to work well for you, right? Make sure your var directory is big enough to handle the system. So that's sort of an infrastructure piece that nobody tells you and doesn't really point out anywhere, but that's really kind of important. So that's volumes. Now, earlier I said exec is this thing that gets used in the Docker community, and effectively LXC uses the equivalent of exec by just SSHing into the container as a way of talking to the container itself, right? Useful, sure, but it kind of breaks, to me, some of the value of containers. The last thing I want to do with a container as an operator is to log into it, find that, oh, there's something wrong with one of the processes or the process that's running. Let me just update that by downloading some new code into this container because I'm thinking of it like a VM. And then suddenly I've now really broken my system because that container image is something I can manage. I can absolutely take a snapshot of it and recover it and reuse it as if it were a VM. But that reduces the value of containerization in my view. Right? So exec is a tool, and absolutely, especially with this massively distributed OpenStack system and the way we've been operating it for years, it's an important tool still today. The containers that are being built are based on an operating system, so they look like Ubuntu or they look like a Red Hat-based operating system when I work with them. Right? And if I need to get in, I can, docker exec bash. Now I have a bash shell. Of course, Vim's not installed, but luckily, they're an operating system, or they look kind of like one, so I can apt-get Vim. Right? Now I'm back up and running. I can actually edit things. But as soon as I edit things within the container environment, I've created a mismatch because that edited file is no longer the same as the one that was in the volume that was attached by disk. Right? So even there, I start to see disparity. So it's best to keep things simple. If possible, find out what's broken in the image, fix that, create a new image, deploy the new image, right? So it is a different operational life cycle. It's a different style for thinking about how you use these resources, but it means that you stay more consistent, right? Oh, and just if you actually do need to become root in your container, because there's no password file, so there's no way for you to sudo to root, that's when you tell it, hey, I want to be root when I start, right? Just another little trick for when you do have to use this tool set, right? So we've already talked about upgrades, but I think it's worth talking about it again. Again, from the perspective of an upgrade, I think one of the most compelling things is the ability to create an image of the next version of your code, whether it be a bug fix or a whole-scale systems upgrade. Install it on the exact same system that you're running on. And installing does not mean run, right? It just means extract the container image into a file system that is actually on the machine now can be run. I have the ability to flip into that new image very quickly. Right? I can stop one and start the next one. By stopping it, I haven't deleted the old one, so I still have the old image there. And so long as this is a stateful service that I'm working with, I don't have to delete anything until I've convinced myself that the new service is running properly. Right? Then I can go and clean up the disk space, recover that disk space for the old version. Otherwise, I can always roll back to the old version. Again, stateful services break this a little bit, right? Because I have to now deal with potentially migration of data. If I know that this is what I'm doing, if I know that I'm upgrading, for example, the database service, within the Docker environment, there are different entry points that I can use. So even within one image, I can say, well, I might have 4 or 5 different process models. One is an upgrade, one is a downgrade, et cetera, to run. And I can use those as different entry points. So I can say, launch my database container, launch my new one, but launch it just with migration as my intent. Right? That's the entry point I want to use. When that finishes, that process may no longer run because it's done. It's done with its migration. It's not going to then just fall over and run the database. Instead, I'd rather that it stop and finish. And now that I know that that state has completed, now I can go and run the system and treat it like a running system, right? And so that's the concept of having multiple entry points. You can do the same sort of thing with LXC because you can also say, hey, run a different process within the LXC container. So this is even possible there, but within the Docker space, this is the concept that exists. Right, so there are ways of building a system that can upgrade and even potentially building a system that can downgrade by maybe dropping rows out of a table, right, so that you still have a consistent model for what your database is supposed to look like. I don't believe there's been much work in the downgrade process, though. Most of it has been in upgrade. Can we get there effectively? Yeah, I think that covers most of what I wanted to talk about there. And lastly, again, with monitoring, this is really, to me, the key value proposition is that I start looking at things as individual processes, but these processes now can be more discrete even than what we've been doing in the past. All right. Even today, if I deploy the Nova API service as a container in Kolla, it will deploy multiple sub-threads from my one master thread. And that's fine. It is a functional way to do it. That's what I think most operators expect. But I think we can go one step further. We can, instead of creating multiple threads of the API service, we can create multiple containers. Each of those containers can now have a restricted amount of CPU so that I don't have one thread taking up all of the available resource of my one container. Right? And that's probably a broken state, but it can happen. Right? And if I do that with separate containers instead, I have finer grained control. I can even limit how much CPU any one container gets. If I share that across then 20 processes or sub-processes within that container, I've kind of lost some of that fine grained control because I can't deal with those individual 20 threads. Right? But I can now monitor the system. I can start to understand how much resource is it actually consuming, because I'm thinking about these as containerized chunks of resource. So I think overall the system becomes a little bit more efficient. Right? That monitoring can also tie into directly letting me know what services really are running. Are they actually consuming consistent resource? Are we getting what we expect out of it? So this becomes very powerful. Now, generally monitoring ties right back into all the same processes that we have in the past. So your Sensu or your Zabbix or Nagios type monitoring can work with this directly. But we can also use some of the newer tools like Prometheus to start monitoring the environment. Now, that may or may not make sense, depends on exactly what you're trying to accomplish and whether you also want to look at some of the other services using that same tool set. But there are newer tools that we can actually start to leverage to monitor these environments too. Right? And there's information that we can get out of the underlying container environment with the cAdvisor tool set to actually pull more fine-grained metrics out of the environment as well. So, conclusions. I think containers simplify operations. Right, so when I'm looking at a system, I have yet to find one where I think it makes sense to go back to the old way of deploying OpenStack. So for me, it's all been Kolla going forward. Right, and that's the last year and a half that I've been deploying OpenStack systems. So even with the older versions of Kolla that still had some bugs and issues, it still was a lot more sensible than what I had dealt with in the past. There are things that you need to learn. There's a different operation style. Logs aren't necessarily where you expect them. In fact, Docker has a logging mechanism. You can do Docker log for your container, and that will show you absolutely nothing, because that's thinking about Docker from a process perspective where the process spits out its logs on standard out. But by default, OpenStack processes are nice. They're daemons, and so they want to run as a daemon, and they expect to put their logs somewhere else. Right? So we have to learn some of these new tricks of the trade, but I don't think it's hard to learn, right? And actually, the couple of things that I showed here were really the biggest gotchas that I ran into when I was trying to figure out why my system wasn't working right. And that's still going to happen, right? Containers don't fix that necessarily, but I do think they make it easier to fix that when you do find something that is broken, right? So overall, I think this really does give us a lead into optimizing our operations because it makes it simpler. We can now focus on making sure that the services are running rather than making sure that we can run the services. Right? So, thanks. And does anybody have any questions?
Have you tried Kolla on Kubernetes?
I have tried Kolla on Kubernetes, but I was using the 4.0 version, so I haven't tried the Pike-based code, and I know a lot of work went into updates for Pike. I haven't tried the latest version. The 4.0 version, I had some issues in the way that I was running it, but I think they were being addressed into Pike. So I think it's worth trying it. I think it's absolutely worth it. There's even more that you have to learn, right? Because to use Kolla Kubernetes, it's good to have the base of the Kolla pieces, right? But then you now have to extend with Kubernetes for one, and you have to have a Kubernetes environment and manage that Kubernetes environment. And secondly, you have to understand how Helm works, right? And Helm and Kubernetes are all Go-based, which means now it's probably useful to actually get a little bit of Go skill as well, Golang skill as well. At least for the templates in the Helm space. It's not hard to learn the new templating language. It's actually fairly straightforward, but it is yet another thing that you have to learn. But other than that, yeah, and I would say that the basic OpenStack Kolla Kubernetes pieces that I was working with worked perfectly. I really had no issues with them at all. There are even some nice benefits. So secrets are managed as a part of the Kubernetes secrets engine. So even though in the end, they still do effectively get written into a publicly accessible, or at least at the control plane, publicly accessible, readable string, they're at least managed in a slightly more secret-oriented fashion, right? So you're actually managing them as secret items that you want to sort of have some control over. Config files, here we were talking about mapping them as volumes on a local disk. In the Kubernetes environment, they get mapped as file system, or they get mapped still as volumes into the container, but they're never really written to the file system. It's just a different way of doing that mapping, but it's an effective way. So I think it's worth it if you have a need for that particular sort of environment, or you already have a Kubernetes environment to work with. All right. Other questions?
How often are the containers for Kolla updated? I mean, first the community released the version of Vanilla or Magnum or whatever, and then the Kolla report will have to be.
So this is interesting. The Kolla community wanted to continue to upgrade their containers, but apparently the OpenStack Foundation has put a hold on that. I don't know quite exactly what's gone on. I build my own. It takes about 2.5 hours to build from source, so using the upstream OpenStack Git repos to build our containers. That's the Kolla bits, yeah. It's very straightforward, especially if you're just using vanilla services.
Yeah, but the community still need to create the templates, the Jinja2 files to create the Docker file.
Okay, so those things are actually fairly static. They do get updated. They get updated basically at the sort of the major release cycle, every 6-month kind of release cycle approach, right? So there's a 4.0 set, and there were some bug fixes, some security fixes that went in. So I think eventually there was a 4.03 version of Ansible, the Ansible code, and that also included then the Kolla base Docker files and templates for that. All right. Now there's 5.0. I don't think there's a 5.01. Right, but so every 6 months-ish or so, those things are being updated.
If you're running multi-node, you'll build your Docker images anyway, so either
Yeah.
all from the vendor repo in your chosen distro or built from.
Yeah, and I think that's the other thing is that I think, let me see, so Red Hat, CentOS, Ubuntu, Oracle Linux, I think there's a Debian. I don't know about SUSE. I haven't looked recently to see exactly the list. I mean, I basically use CentOS and Ubuntu when I build images.
It's not in there, but there's no reason you couldn't
It would take some work because you want to end up using YAST for any packages that would need to be installed, and that kind of code base isn't exactly there. At the same time, I don't know if you've pinged any of the folks in the Kolla community. They have been incredibly helpful. I think one of the most open groups that I've worked with in the OpenStack community, and everybody's great. I'm trying to say anybody's bad, but I mean, those guys, I've always gotten a response. I had the craziest of problems, and I'll get somebody to say, well, I'll look at it, and then maybe they can help, maybe they can't, but there's always somebody who responds within a couple hours.
We use Kolla Ansible. The reason we use Kolla Ansible is because the Kolla community is very friendly.
Yeah, they've been really great. Okay. Well, if there are no other questions, then thank you guys very much. I'll stick around a little while too if